Hi, I'm Musab with Autel. Alongside is my colleague Mike, and I will introduce the MaxiCharger DC Fast and how it's produced. We will take tours of different factories that produce different parts of the products. The DC Fast has a power range covering from 60 to 240 kilowatts. It can perform DC fast charging for all electric vehicles, including passenger cars and commercial buses. It's mainly composed of charging controllers, modules, and cabinets. The charging controllers is the brain that determines success or failure of charging. The charging modules, it's the energy, and it determines the efficiency of charging surfaces. And the cabinet is the trunk, and it's determining the service life. Now, let's take a look and see how the DC Fast is produced.
Welcome everybody. I'm standing here in our factory for printed circuit board assembly, or PCBAs, for our MaxiCharger DC Fast. Right behind me is the SMT line, which stands for Surface Mounting Technology. This is where we take a blank circuit board and solder on most of the components that make up a complete PCBA. Now this process happens twice, once for the top of the board and once for the bottom of the board. Let me take you through this process step by step. Let's go. So our first step in this process is for the boards to go into this machine. This is where the solder paste will be applied to the circuit boards. It will be applied directly onto the stencil into the holes where the components will eventually go. Once it comes out of this machine, it will head into this inspection machine to make sure that the solder is applied in the correct spot. Once it passes inspection, it will head into this machine. This is the pick and place machine. It picks out the components and places it onto the circuit board. Once it comes out of the pick and place machine, we need to put it in the reflow oven. This is the reflow oven. It will melt the solder so that the components stay in place. This process takes about 5 to 7 minutes. Once it comes out of the reflow oven, it heads into this inspection machine, the AOI, the automatic optical inspection. It will shine a rainbow light, many different colors at many different angles. And then it will take pictures of those angles, of those components. A technician will compare those pictures with pictures of a perfectly placed board. If he notices any misalignments or mismatches, it will mark it as a defect and it will not be used for production purposes. Now we have the top half of the board, but we still need to do the bottom. So now we can do the bottom by going back and redoing that whole process again. Once we have the top and the bottom of the boards completed, we're still not done. We still have some bigger components that we can manually plug into the board. This happens upstairs on the DIP line. Let's go check it out. Now we're up here at the DIP line. This is where we take those completed printed boards from downstairs and bring them up here. We can put them on this special fixture for stability. Once the technicians put it on here, the technicians will manually place those larger components onto the board. Once all the larger components are in place, the board will go into the oven for solderization. This process takes about 4 minutes. Once it comes out of this machine, it will be manually inspected by some technicians, just to check if there are any defects or any misalignments. Once it passes inspection, we will head over to the testing area to upload our information into the back system and test the board to make sure it's working properly. Let's go check it out. So now that we have our completed boards, we can bring them over here for testing. We scan a code on the board and upload all our information to the back system. This helps us track the board. Once here, we can perform tests like the power circuit test, serial circuit test, and other tests for key components on the board. Now over here, we perform an aging test. So here, 10 minutes of testing will simulate about 1 year of actual use. Once the completed PCBA is assembled into the DC Fast, we will undergo another 8-hour aging test to guarantee its 10-year working life. So you just saw the full process for a complete PCBA. I hope it was informative. Thank you for watching, and I'll see you next time.
Hi, I'm Musab from Autel, and I'm standing at the factory for the MaxiCharger DC Fast display assembly. Behind me is the production line, and here I will show you how it goes from a piece of glass to a complete touch screen. Let me show you step by step how it works. The MaxiCharger DC Fast display touchscreen is divided into 3 layers. The outermost layer of the tempered protective glass, the middle TB touch component, and the intermediate LCD display component. The first step of the production line is the production of the TB sensor, which is responsible for the touch operation function of the MaxiCharger DC Fast screen. This machine completes the production process of the touchscreen sensor through cleaning, printing, etching, laser engraving, and pressing. This step is to bond the outermost toughened glass of the TB sensor and the MaxiCharger DC Fast touch display screen. The CCD camera in this machine automatically grasps the target alignment to ensure the accuracy of the toughened glass and the sensor fitting. Then the sensor and the cover plate are bonded by the vacuum press machine, which then press through the forming machine to eliminate the air bubble in the lamination. After that, it's ready for the next step. The next step is to glue the LCD module and the previous component together. It's by filling the gap between the LCD and the TB with glue to reduce the reflection and to improve the transmittance of the display screen. So the display screen visually will be clearer and the colors are more saturated. The final completed touch display assembly will be tested here to check whether it's functions normally. At the same time, to confirm whether there are foreign objects in the TB and the LCD module, light leakage around the display, including whether there are more bright spots, dark spots in the display, and lastly, whether there is color deviated. This checks to ensure that 100% good products are shipped. This is the experimental center of the factory to verify the reliability of the display touchscreen for the MaxiCharger DC Fast. There is special testing equipment to test the composition of the material, which can monitor the composition of the ink to ensure the correctness of the ink used. And there's our environmental testing equipment, which simulate the harsh environments of various outdoor settings. With this reliability verification, the processed raw material can be effectively controlled and monitored to ensure the long-term reliable use of these products outdoors. So that's how we make our display for the MaxiCharger DC Fast.
I'm standing in a factory that makes the outer shell for products such as our DC Fast. On this floor we have technicians and machines helping with sheet metal forming. For sheet metal forming, we take a flat metal sheet, apply pressure to it, and form it into our desired final shape. This is where the metal for our DC Fast will be pressurized, form into the outer shell of our final product. After sheet metal forming, the outer shell needs to undergo welding. Then after welding, we need to perform pre-treatment, cleaning, and phosphorization. Then it needs to be spray finished. We spray it twice, once for the priming coat and once for the final coat. This ensures that for outdoor products like the DC Fast, we can prevent against rust and we increase service lifespan. After it is spray finished, the outer shell is then assembled together. The shell then undergoes extensive waterproof testing to ensure it is 100% rainproof. We also do a solar radiation test to verify its heat dissipation capacity. You just got an exclusive look for how we produce the outer shell for our MaxiCharger DC Fast. We undergo sheet metal forming, welding, painting, assembly, and waterproof and solar radiation testing.
We have already seen the machining process of the key component of the MaxiCharger DC Fast. Now we will put this component together to form the final product. Considering the large number of parts required for the DC charging product, we use a modular processing process. This reduces the processing time of the main production line by presetting parts including wire processing, screen assembly processing, DC output assembly, etc. In the view of the large size and the heavy weight of the DC charger, we use a multi-speed chain line for charging pile assembly. A single station completes the whole operation, and a flow of personnel ensure the uniformity of the process, which include reliable wiring. When all parts are assembled, we will test and verify the equipment to ensure that each of our products are qualified. First of all, and before leaving the factory, we will conduct safety testing on the products, such as product voltage test. We test 10S at 2000 voltage, which monitors leakage current. We also conduct product insulation resistant test and grounding resistant test, all that to ensure that the products meet safety requirements and there is no risk for outdoor use. Secondly, we will conduct a full function test, charge control function test, communication function test, insulation detection test, recharge function test, input and output over voltage protection test, output current and voltage setting error test, voltage and current stabilization precision test, etc. to ensure that our products are well wired, function perfectly, and the product quality meets the customer requirement. And finally, we will do the whole machine full load test for 8 hours, while taking infrared images for the cabinet every 2 hours to detect the full load test temperature. This process is not available in many companies. I hope you enjoyed our tours of the DC Fast factories and learned a good bit about how we produce them and the technology behind them. Creating trustworthy products that improve businesses and contribute to the local community's well-being is what motivates us. I'm Musab with Autel, and I would like to thank you for watching.